Hello, 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 hello. How is everyone doing? Welcome to our second Steam Forward session. If you missed the first one, please don't lose heart. Southwest Africa has uploaded it on our YouTube page. Hello, 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 hello. How are you guys doing? Hello to to kids out there. Hello. So again, I said this is our second session. Please, if you missed the first one where we learned how to do our own lava lamp, how to blow up a balloon using chemistry, please just go and check it out on our YouTube page. We've uploaded it. It's there and it's ready for you. Today, we shall be doing making our own ice cream. I hope you guys are excited. I hope you have all the ingredients. Please, if you can and if you're willing, please put your cameras on so that we might be able to see what you're doing on that end of things so that we can engage better. If you do take photos, hello. Can you, so again, house rules, if you're not speaking at a moment in time, we'll ask you to switch off your microphone so that there's no feedback, and when you decide to talk or if you want to ask a question, then you can switch it on and ask a question. Okay, great. So again, as I go back, if you're going to be taking pictures, please feel free to post them on our Facebook page or send them to us on an email address, media@cyfest.org.za, and we will post them for you on your behalf. We are excited to see what you're doing on that end of things, and please do feel free to give us feedback. Today, Jeanita will take us through making our own ice cream, and then after her, we have a special guest that is going to speak up to us about a book that she wrote. Stephanie, please just stay tuned and be expecting to hear great stuff about the work that she's doing. I will not talk much because I'm not the center of attraction, so please allow me to just hand over you to Jeanita. Jeanita, please take over.
Good morning, everyone. Thank you so much, Freddie, for the introduction. Thank you for everybody joining, or actually I should say good afternoon to everyone in South Africa. It is currently 9:05 a.m. here, so we are gonna have ice cream for breakfast, so how cool is that? I'm gonna switch on my other camera just so you all will have an opportunity to see what we are doing here. As Freddie mentioned, if you guys do take any pictures or if you're comfortable turning on your video camera, please do so that we can share what you're doing with the world. We want everybody to join us in having fun and learning all about these fun STEM activities. So again, for those that did not join us last week, I'm Dr. Jeanita Pritchett, and we're gonna take you through a really fun experiment that's gonna get you a nice cool treat at the end. And afterwards, we're gonna hear from one of my near and dear friends, Dr. Stephanie Ryan, who's gonna talk to you about a little bit about her career path and how she has just written a book all about chemistry for kids. So what are we doing today? Well, last week, if you guys remember, we talked all about chemical changes. And remember when we did that DIY lava lamp, we learned that in a chemical change, something new must be formed, right? So we did a chemical reaction where we had that acid and a base that reacted with each other. And as a result, we were able to create those new products and see the bubbling occur. Well, today, what we're gonna be doing, we're gonna be focusing on physical changes. So physical changes are a little different than chemical changes. In a physical change, nothing new is actually formed. Most physical changes, they're just gonna evolve, changing the outward appearance of the material, but not creating something new. Remember, with a chemical change, something new must be formed, but in a physical change, just simply the outward appearance is changing. Maybe that means the texture or the color is changing, but the overall composition of that material is remaining the same. So as we're doing this fun experiment, remember what we're doing is doing a physical change. We're gonna be changing the ingredients we start with into just a outward appearance that looks a little bit different, okay? So what are we gonna be doing? We're gonna be making ice cream. And the reason we're making ice cream, well, one, it's delicious, but two, the overall experiment is a great demonstration of not only a physical change, but also a concept known as freezing point depression. And we'll talk about what that is in a little bit, okay? So I just wanna get you guys a little bit calibrated on what we're gonna be working with and the types of things that we may be expecting. So one of the things I like to show when I start off any chemistry class is the idea of what matter is. So we can talk about what are the different types of matter and the changes they can undergo. So matter is pretty much everything around us. So matter is anything that takes up space and has a mass. So that's everything, right? And so matter can be further broken down into two subcategories of, is it a pure substance, meaning a singular thing, or is it a mixture of multiple things, two or more things? So we're going to be focusing on this mixture side today. We're going to be making actually two different mixtures that we're going to be exploring. Now, the different types of mixtures that exist are called homogeneous mixtures or heterogeneous mixtures. In both of our cases today, the two we'll be dealing with are the homogeneous mixtures, okay? Now, a homogeneous mixture, that prefix means the same. So a homogeneous mixture is anything that has two or more things in place that we can't visually separate. They look the same throughout. It's uniform. And so our ice cream mixture that we're going to be making represents a homogeneous mixture. And we're going to be taking that mixture through a physical change. Okay? All right. So what kind of physical change are we going to be dealing with? One of the most common physical changes that are out there are phase changes. We all know that there are a few different phases out there, the most common being solids, liquids, and gases. And a material like water has the ability to go through all the phases. So we know water can go from being solid ice to the liquid version to the gas version and back and forth. Remember, in a physical change, nothing new is formed. So in each of these situations, it's still water, it's just the outward appearance has changed, okay? And so that's what we're gonna be doing today. Now, in order to go from this gas to liquid or liquid to solid, and in our case, this is gonna be what we're gonna be doing, this liquid to solid change, we're gonna need to cool down the mixture and slow down the molecules that are there. We want them to all lock into place and form that really delicious ice cream for us, okay? So Jim, if you could switch to my other camera so I can talk about the ingredients that we're gonna be using for the day. All right, so hopefully you all were able to see our ingredient list from the post or from your registration. So a couple ingredients you're gonna need. Our main ingredient is your milk substance. So I'm using half and half, but you can also use regular milk, you can use low-fat milk, you can use a non-dairy alternative if you have any lactose issues, but this is gonna be the base of our ice cream, okay? And we'll get into that in a minute. You're also going to need some salt, and we'll talk about why we need the salt. A little bit of vanilla extract, because we're going to start by making a basic vanilla ice cream, but I'll talk about how you can change the flavor. You're going to need some sugar. Here's my sugar. Some ice, okay? Some measuring cups or measuring spoons. And for this, we can approximate about what we're going to need, but I do have some measuring cups and tools here for me. You're going to need 2 bags, one Ziploc bag that's a large size, that gallon size, and then one that is also the smaller size, like a sandwich size bag, okay? If you want to make any toppings or add flavor to your ice cream, you can obviously have your chocolate syrup, your M&Ms if you like it, sprinkles, whatever you may put, or a cone, or you're going to see we're going to be able to eat right out of the bag. Because we're going to be working with a cold material, you may also want to go grab a towel or some paper towels or an old t-shirt, something that you can wrap that bag in, okay? So take a minute, parents, if you are around, go grab a towel if you don't have one in your kitchen accessible or in your room accessible, so that you can hold your bag easier, okay? All right, so what are we gonna be doing? We're gonna be creating this homogeneous mixture. Remember, I said a homogeneous mixture is something that has 2 or more things in it that we cannot visually see a difference. Okay, it's gonna look the same throughout. And so that's gonna be our ice cream. So go ahead and get your small bag, all right, and we're gonna open that up. And open it up and just kind of sit it standing up a little bit so that you can easily see and add stuff to it. Okay, so everyone get your bags open. All right. And again, if you don't have measuring spoons, it's perfectly fine to get your traditional spoons that you may eat with, and we're going to approximate with those as well, okay? All right, so the first thing into our homogeneous mixture that we're going to be adding is our sugar, okay? So sugar we're gonna be adding because we want our ice cream to be sweet. Now, if you're not into sweets, you don't have to add the sugar part, but to make it a little more flavorful, I do suggest adding a bit of sugar. So you're gonna wanna add about 1 tablespoon of sugar into your bag. All right, so I'm gonna find this one does not actually have a tablespoon. It actually has up to a half tablespoon. So I'm gonna add 2 of these so I can equal up to 1 tablespoon. If you're using the traditional spoons, your tablespoon is gonna be the larger spoon of the 2, okay? And so I'm just gonna get a scoop. And make sure whenever you're getting your sugar, when we're measuring, we wanna level it off a bit so that we don't have excess amount that are going in there. We wanna be careful with our measurements. And so I'm gonna add 2 scoops in there to equal out my 1 tablespoon. Okay, it's about good, nice and leveled off. Okay. Okay, so hopefully everybody has your sugar added to your bag. Next, we're gonna add a little bit of vanilla extract. Now, remember, we're gonna start with vanilla ice cream, but again, if you wanna add chocolate or strawberry syrup or anything like that to change the flavor, you're welcome to, but definitely add the vanilla just to give a little bit of flavor to it. Now, this is an extract, which means that it's very, very concentrated. There's a lot of the vanilla that's in here in a reduced form, and so we don't need a lot of this. We only need a really small amount. You can add about 1/4 or up to 1/2 of a teaspoon into your bag, okay? So the teaspoon, that's your smaller spoon out of the 2 big ones. So you're gonna go with the small spoon. And you don't need to fill it all the way up if you're using the traditional one. You want about halfway full or about 1/4 full to add in there, okay? I'm gonna switch over to my measuring. And I'm gonna go to the one that's for 1/4 of a teaspoon. Okay, and we're gonna open it up. Again, you never wanna drink this straight on because it's really just too strong and it's not gonna taste that good. We only need a small amount in our mixture to give us our nice flavor. Okay, so I've added some here and I'm just going to drop that in my bag. Okay. Hopefully you guys have a nice covering down just to try to catch any mess. Again, science can get messy, but that's the fun part about it. All right. And then one other thing we're going to add to our mixture, or you, again, like I said, can add the flavor, is your milk substance. So whether it's your half and half, which I've learned that half and half is not something that's in South Africa, but in the States we have what's called half and half, which is a mixture of milk and cream, about 50-50 mixture, which is why it's called half and half. But you can use, like I said, regular milk, an almond milk if you have any lactose issues, or soy milk, some type of milk product. Now, this could become a really great chemistry experiment where you could vary and try different types of milks to see what kind of results you get. Each one of the milks that you may use will all have a different amount of fat in them. And so that's gonna dictate how creamy your ice cream is gonna come out, okay? So just keep that in mind as you're thinking about how to expand on this experiment. So for this, we're gonna need about 1/2 cup of the milk substance. And 1/2 cup is the equivalent of, I believe it was 125 milliliters for the metric system users. All right, so one of the cool things I always like to point out whenever we think about chemistry and measuring things, when you're measuring in the kitchen, it's the same process that you would do when you're working in the lab. What you may notice, you guys may see, I have a few of my little demos over here. In our lab equipment has these metric lines, these gradient lines that we use to measure. Well, notice our kitchen equipment tends to have the same things. You see the lines. And so we're going to be adding our substance in there and measuring off of that. It's very important when you're doing your measurement not to look at it from top down to see if you have the proper amount. You really want to get eye level, hopefully you guys can see me, get eye level and look at it head on and try to see the bottom of the meniscus. The meniscus being that concave area that shows up in the at the top of the liquid. Okay, that's to get a more accurate measurement. So again, we're going to need about 1/2 cup. So my measuring cup, this is for a full cup, if I put it up to the top, I'm gonna go to just the halfway mark. Again, the recipe that we're following, this is for a single serving. And so if you wanna increase it, obviously you can double all the ingredients to make a larger portion. So I'm gonna pour some in here. And before I am done, I'm gonna just make sure again I get eye level and ensure that I am at that halfway mark. I'm a little low, so I'm gonna add just a bit more. And again, this doesn't have to be an exact science, but this is the procedure that you'd be going through in the lab, okay? So we now have our cream or our milk or our almond milk or our soy milk, something in your cup, okay? And we're gonna now add this to our bag. So make sure you hold your bag up and carefully pour into the bag. Now again, remember, this is considered to be a homogeneous mixture because we've added 3 different things. And after we give this a bit of a shake, you're gonna see that from top to bottom, it's gonna looks the same. It's gonna be uniform. Now, before you seal your bag, you see how there's a lot of air in here? Try to get as much of that air out of there before you completely seal it. So start closing it a bit and then try to push out as much of that air as possible and then seal it up. You may not get all of it out, but you want to try to get as much out and just blend that stuff together. Okay, now notice I can no longer see my sugar or my vanilla or the cream independently. They're all look the same. It's well blended. This is what we call a solution. Solutions are things that have multiple things that have been put in there and they've been well blended. Solutions consist of things that are called solutes, which would represent like the sugar and the vanilla extract, and the solvent, the cream, the heavier part that allowed them to dissolve in there, okay? So give it a good blend. And again, try to seal it to get as much of that air out of there as possible. I'm just gonna open it up, get it nice and tight, like so. All right. So this is going to become our ice cream. And as I mentioned, if you want chocolate flavor or if you want strawberry, you can add a bit of your chocolate syrup to it at this moment or before sealing it, okay? All right, so at this moment, we still don't really have the ice cream. Ice cream we know is cold. Ice cream we know is more in the solid form. Right now, we are dealing with something that's in this liquid form. So we want to get our liquid to become a solid. And the way we're going to do that is by cooling it down. We need to take these molecules that are freely moving and slow them down so that they form this solid material. This is where our ice is going to come into play. Ice, as we know, is just solid water. And it freezes at 0 degrees Celsius or 32 degrees Fahrenheit for us in the US. And we're going to use that to help cool this down. But we're going to add a little something else to our ice. So grab your big Ziploc bag. Okay. And we're going to put some ice in here. Now you don't need to fill it all the way up to the top. I would say maybe fill it about maybe just over halfway full with some ice. Okay. So add some ice in here. I may grab a little bit more because some of mine has started to melt a little bit. Give me 1 second. Let me grab a little bit more ice. That should be good. Pop it into our bag. So we now have our ice. Now, before we place our milk mixture, our cream, or our soon-to-be ice cream in our bag, we're going to add something else to this. Now, we know ice is cold, obviously, but we want to try to get this a little bit colder. And so what we're going to be adding is some salt. Well, why are we adding the salt? The salt is going to act as a new solute in this mixture that we're going to create in this bag, okay? So the salt, again, is going to act as a solute, whereas the water, the frozen water, that's going to melt a bit, is going to be a solvent, And that's going to create a new solution for us. Now, this new solution is going to have a different freezing point than our solid ice. Ice, like I mentioned, when our water freezes at 0 degrees Celsius or 32 Fahrenheit. But by adding this salt, it's going to be able to make the freezing point go down through a concept known as freezing point depression. In freezing point depression, when we add a solute to a pure solvent, in our case, the salt to the water, it causes the freezing point to get lower, essentially allowing the solution to remain colder before it starts to freeze. And that's what's going to help us really get our ice cream frozen, okay? So we're going to be adding some salt. So we're going to need about 8 tablespoons or half a cup, or I believe it was 125 milliliters, whichever metric you're using. And so I have another measuring cup here. So I'm just going to add, this is my half cup. Going to fill this up. And if you've ever used the old school ice cream maker, the one that has like a kind of a churn on it, you add this ice and rock salt mixture around it to help get it nice and cold, okay? So put my salt in here, and I'm just gonna add this directly to this big bag, okay? Now, again, that salt is gonna be able to interact with that water as it's melting and allow that solution to become colder. After you've added your salt to your bag, you're going to go ahead and take your cream mixture and drop it in there. Okay, now this is where the workout comes. You want to, again, try to squeeze out as much air as possible out of here and seal your bag. Make sure that both bags are sealed before you get started, okay? So the next part is where we're going to put a little work into this to get our ice cream frozen. All right, so we're going to start shaking this. So this is why I said grab a towel to help you out, because it's going to get a little cold. So grab your towel, wrap it around your towel, a t-shirt, anything, and start shaking. So we're going to have to shake this for about 5 minutes, okay? So parents, you may need to help your little ones, or if you have some siblings there, ask them to help you out. But we're going to shake, 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 okay? So if you want to switch over to my main camera, Jim, while I sit down and shake. Hopefully we can see you all shaking, and keep checking in on your mixture. Try to get it in that ice and shake it up. So shake. All right, try to move it around, get that ice really around that solution. You can also, if you have a really large jar, you could have put the ice in the jar and then rolled it around. All right, so shake it up, shake it up. I see you shake it. Yep, shake it up. Yeah, bounce around. I see you, Caleb. Shake it up. So not only are we doing science, we're also getting a bit of a workout. Hey, Charlie, I see you shaking it up.
Hi.
Hi. Shake it all around. Again, that salt is going to help cool down that water and allow it to get even colder. If we were to put a thermometer in here, we can see that this solution could get down to almost 10 degrees Celsius. Excuse me, negative 10 degrees Celsius. Okay? Keep shaking it, keep shaking it. That's gotta work. You didn't know you were getting a workout as well. Okay, really work it around. Try to get that salt all nice and mixed up. I see you guys. Yep, get that energy. Yep. What we're doing here, we're drawing the heat out of that ice cream mixture so it can cool down. We're slowing down those molecules. And they're going to start forming a solid substance. Get it all around. I'm just gonna quickly check to see how mine is doing. See how much more shaking we have to do. Oh, you can see it's already starting to get solid. All right, a little bit more. I want a nice firm ice cream. So put it back in my bag. Get back to shaking. Again, try to really get that ice mixture around your cream. Okay, I'm gonna shake it probably for another minute or so. Again, check on your bag, see how it's doing. You guys are working. The ice cream is gonna be so well worth it. All right, I think I'm almost done. Again, different types of milk or cream or non-dairy substitutes may take a little longer because they all have different amounts of fat, but the result will be the same. All right, I think I am almost done. Shake it up a little bit more.
Hi, Janita. There's a question here. It says, is it true to say the more the ice, the better? Maybe the
So
quicker.
the more ice, the better, but you don't want to fill it all the way up. If it's too full, then you won't be able to shake it around as much. So you don't want to fill the bag completely up, but you want to have a fair amount in there, okay? Ooh, almost dropped mine. All right. Let's see where we're at. All right, mine is feeling pretty solid, so I think we're pretty much ready to go here. I'm gonna go back in here. Jim, can you skip the perfect? Thank you. So what we can see here, I have a nice, see, solid ice cream. All right. So I do encourage you before you try to eat this, grab a paper towel and a little bit of water and wipe off the bag, or else it'll be a little salty. Put my ice to the side. So you can just wipe off the bag. And if you want, you're perfectly free to just go ahead and open it up and eat right out of there. Or if you want to be a little fancier, you can open it up. You see, we have a nice solid material that's formed. And I'm actually just going to scoop a little bit into a bowl for easy access. I'm just scooping it out. All right, or like I said, you can eat it directly from your bag. But you can see we got a nice solid material that's been created here. We try to scoop as much of it out as possible. It's 9 a.m. here, like I said, so this is going to be my breakfast. It's Friday, so it's okay. Cheat my diet a bit. And there we go. Looks yummy. So let's try to scoop as much out, or like I said, you can eat it directly from the bag. If you want, you can go ahead and add some toppings to your ice cream. Blue, yay. I'm an M&M fan, so may add a few M&Ms to mine. And voila, we have used science to create some ice cream. So again, what we did here, we started with a number of materials to make a homogeneous mixture. That was our vanilla, our sugar, our cream or milk substitute. We then put that in a bag. We put some ice and salt in a bag, and that salt allowed the freezing point to go down. We used freezing point depression, And that allows this solution in here to become even colder. Again, this is really cold. If we put a thermometer in here, could measure up to like -10 degrees Celsius, so really cold. And we've been able to create this delicious treat by just simply shaking around. And if you don't believe me that it's great, you can test it yourself. All right. How's everyone's ice cream? Oh, yay! I see Stephanie's ice cream and Charlie. See you guys enjoying it. Yes, go ahead and show us your ice cream. Put it towards the camera so we can see what you guys made. Here is mine. I see you guys enjoying. Yes. Awesome, guys. All right. So while you guys are enjoying your ice cream, I hope everyone enjoyed that fun experiment. Super easy, but we learned a lot of concepts. I did want to introduce to you all one of my near and dear friends, Dr. Stephanie Ryan. Dr. Stephanie Ryan and we went to graduate school together. So we met in graduate school while we were both pursuing graduate degrees, and we worked in the same research group. And so Dr. Ryan has just released a book called Let's Learn About Chemistry. And it is a super fun book. I use it with my niece all the time. So parents, if you're looking for a really great educational tool, this may be something that you are interested in. So I'm gonna share a screen real quick, but I'm gonna turn over the floor to Stephanie so that she can tell a little bit about her career and about her book. So Stephanie, if you wanna go ahead, please take it away.
Hi, can everybody see me? Did it switch?
We're looking at Jeanita's slides. So
we can see the book.
It's okay if you can't see me. We can talk.
Here, so what I'll do is I will stop sharing for right now, and I will share it in a second.
Okay.
All right, so go ahead and pin Stephanie, please.
Now?
Yes.
Okay. Well, as Jeanita said, I went to graduate school at Jeanita. I went to school for chemistry. And while I was in graduate school, there was a program where they sent scientists to work with kids in schools to help people become better public speakers, to send out their research to the public. And by working with children, you would be able to explain your research at a different level. And I ended up loving it so much that instead of going for my PhD in chemistry, I got my master's in chemistry and switched over and started doing how people learn chemistry on the education side of it. And that chart that Jeanita showed you, the states of matter chart, one second, buddy, mommy's talking. The states of matter diagram that she showed of how things are separated easily, I started thinking about that one day while Charlie was playing. He was sorting his toys into red and blue piles. And I thought, whoa, wait a second, a lot of chemistry is this way. We sort things into categories, and I think we could teach this to kids a lot younger than we are, and it would help them when they get older. And so instead of this niche market of like, I'm getting a science nerdy book for my baby, maybe I could actually get something that really goes with the way they actually learn content and also have fun with it. So as you see Charlie right here, this is Charlie in the book, and these are his 3 best friends from when he was a little baby. And what I did is I asked their parents, with permission obviously, to have the illustrator get their likeness and then all of their favorite colors, their favorite games, their outfits. So these 4 kids I'm going to, buddy. And what they do is they play a game. So I took this book to Charlie's class at daycare at preschool, and I read it to them, and the kids were needing a little guidance in same or different. So I did this activity where I asked everybody about their clothing and their shoes. So I started out the book this way because it worked so well, was that, look, we're all wearing clothes right now. That's the same, but my clothes are different than your clothes. So they're different, but they're still the same, but different in different ways. And so what the game is first the kids get introduced to each other, favorite colors. So Charlie's favorite part is I say, his says, my name is Charlie, what is your name? And then all the kids, whoever you're reading it to, they answer these questions. So your favorite toys, your favorite stuffed animals. So it's a game to get them involved with their own favorite stuff, because a lot of these, food.
Yep, and food. And drinks. A lot of the concepts you can use around your house. So like these rocks are all solid, but my milk is a liquid, and things like that. So
The first page is perfect for this. It's which of these things are not like the other. You've got scissors cutting paper, water, ice cubes melting into water, an egg frying, and water boiling. And it's which of these is not the same. And the illustrations are done such that there are lots of different answers. So I've had kids say these are all 3 things you can eat and put in your mouth, and you can't do that. Kids will say this one's green and these are not, and all of the answers are fine. And that is how I made this book. It's more about observations of putting evidence with your claim. So it's geared that way that 3 kids could say 3 totally different things, and as long as they can back it up, that's perfect. And then I have a science answer off to the side for the parent in case they aren't scientists. Because okay, 1 second, bud. I'm still presenting my book. Do you want to go over there? So my husband is not a chemist, and he told me he thought that the first version of this was a bit off-putting because he didn't know the answers. And he was like, so I wouldn't want this if I didn't know the answer. It would make me feel a little dumb. And so I went through with a developmental editor who works with children's books, and she helped me think of a way to make this so that even a person who's like, I didn't like chemistry in school, I don't think I can handle this, it is so they can do it as well. And it's perfect for what we just did because we've got a section liquids and solids, and it's got dolls and milk and things that people play with, like blocks. And so it's easy to substitute other toys that you could say, what other solids are in my house, and things like that. We got gases and liquids, and we get even into micro and submicroscopic. And my favorite page is the multiple levels of representation. You've got water, water, and water, and a dinosaur. Which one of these is different? To show that you can talk about these at different levels. And so this book is really for, like, it's a board book, so you can chew on it and drool on it like babies do. So we say 0 and up, but the baby doesn't get as much out of it, obviously. But different levels of kids get different levels throughout, and you can keep using it and get more in depth whenever you want, and you can just do it for fun as a game as well. So that's Charlie's book. Charlie, no one can hear because you're singing.
Thank you so much, Stephanie.
Thank you for having me come on, Jeanita. I've got a code, and I've got it in the chat for you. I know a lot of you are international. My distributor does ship internationally for the book, so I've got a half off the book code to make sure that you can kind of offset for shipping a little bit. It's also available in Amazons across the world, and their ebook versions. So there are lots of ways to get it. I think the board book is the best because it works best in person, but the ebook is good if you're traveling because it's not as heavy.
Awesome. Thank you so much, Stephanie. Like I said, I use this book with my niece when I get to go home, and she loves it. So definitely, if you're interested in learning more about chemistry and just science in general, I encourage you all to check out her book and utilize the promo code that she's provided for you. I believe you said you've already dropped it in the chat box, and we'll make sure that the SciFest organizers send it out to you all. With that, I'm going to stop sharing my screen. Hopefully you guys got that information. But I hope you all enjoyed today's demo. Remember, if you've taken any pictures or any video, please make sure you tag SciFest Africa on there when you're posting them so that we can just capture and share all the exciting things that we're doing during STEAM Forward activities. We look forward to having you guys back next week. Next week, we're going to be doing chromatography butterflies and butterflies and flowers. And so it's a more arts-based activity. So we're going to be doing a little STEAM versus STEM, and we'll talk about all that next week. I hope you all enjoy your ice cream, make some more. If you do some more, post pictures of it, definitely tag SciFest Africa. You can feel free to tag me as well on Facebook. My name is just Jeanita Pritchett. I'm also on Instagram as Dr. Jeanita Pritchett and Twitter as Dr. Jeanita, so Dr. Jeanita Pritchett. Again, have a great rest of your day, and we will see you guys next week at our 3rd STEAM Forward session. Have a great day, and we'll see you all next week.
Thank you.
Bye.
Thank you. She can't see.